So we're going to talk about odd and even functions, and you can look at the two graphs here and you can see that an even function is something that's symmetric about the y-axis. So if you fold along the y-axis, the left and the right side are going to match up. If something is odd, it would be symmetric about the origin. So if you look at the picture on the right, that is symmetric about the origin. And basically what I usually say is if you can take the picture and you can turn it upside down, and it looks the same as it did right side up, that means it's symmetric about the origin, and that would be an odd function. So again, over here on the left, this would be an even function, and over here on the right, this would be an odd function. All right, now if you look below, you'll see that we also have rules for an even function, an odd function. These you should have seen before, so we're going to cut to the chase. If you look at the packet that you were given, we're going to start by looking at number 2. All right, so if you look at number 2, what we're going to do is we're going to try to prove whether it's odd, even, or neither. So usually what I like to do is I like to start with f of negative x. So now just remember that this is also, y is the same thing as f of x, so instead of writing y equals negative 3x to the 4th plus 5x squared minus 7, I could say f of x is equal to. So when I want to find f of negative x, what that's basically asking you to do is everywhere you see an x in the equation, you're going to replace it with a negative x. So here we go. And then in this case, I'm going to raise it to the 4th power. Okay, plus, I'm going to bring down that 5. I see an x, so I'm going to replace it with a negative x. And then I'm going to raise that to the 2nd power. And then minus 7. Okay. So I'm going to go ahead, I'm going to keep simplifying this a little bit. So I'm going to keep the negative 3 for right now. And then I'm going to say negative x if I raise that to the 4th power. Well, a negative raised to the 4th power is a positive. And then x raised to the 4th power would just be x to the 4th. Plus 5. And a negative raised to the 2nd power is a positive. And x raised to the 2nd power would be x squared. And then the 7 doesn't have an x, so we just bring it down. All right, so let's just take one more extra step. We'll simplify all of this. Negative 3 times x to the 4th is negative 3x to the 4th. Oopsie. Then we've got plus 5x squared, and then minus 7. Now, if you look at what I have here, and you look at the original equation, you can see that those equations are equivalent. So since the original equation, f of x, is equal to, f of negative x, then we say that that function is even. In other words, symmetric with respect to the y-axis. Okay? All right, let's look at the next one. So we're going to go to number 6 in your packet. We're going to do the same thing. So again, keep in mind that this thing technically is f of x. It's the same thing as saying y. So I'm going to start again with f of negative x. So remember, everywhere I see an x, I'm going to replace that value with a negative x. Okay, I see x squared, so I'm going to go negative x, that quantity squared, minus 5 times negative x. Alrighty, so let's simplify that a little bit, and let's see what we end up with. So in the numerator, I'm going to have a positive 3x. In the denominator, negative x, if I square that, is x squared. And I have plus 5x. Now, if we compare the original to my f of negative x, you can see that they're not the same. So that being the case, this is not even. Now, when that happens, then what I usually do is I go one extra step, and I'm going to find negative f of x. Now we have to be a little careful with this one because negative f of x means take whatever you have and negate everything. However, this is a fraction, and when you negate a fraction, you can't negate what's in the numerator and the denominator, because if you do that, really technically what you're doing is you're multiplying the numerator by negative 1 and the denominator by negative 1, which really is just 1, because negative 1 over negative 1 is just 1. So when you're going to be negating a fraction, you have to pick either the numerator or the denominator, it doesn't matter by the way, and negate one of them. So I'm going to start by just taking, I don't know, the numerator, and I'm going to negate that. So then basically all I'm going to do is negative, come on, of negative 3x, okay? And then I'm going to keep the denominator as is, because again, if I negated the bottom as well, then I'm really multiplying by negative 1 over negative 1, which is positive 1. Okay. All right. So now in the numerator, I'm going to get 3x, and in the denominator, I'm going to get x squared minus, 5x. All right, so now let's compare this, because the rule for odd is that your f of negative x has to equal your negative f of x. That's your rule for odd. So that would be these two guys right here. Let's look at them. Well, their numerators are both the same. Their denominators, however, are not. So in this case, since it's not even and it's not odd, then our answer would just be neither.